Inequality involving quotient. So this time we have a quotient, a fraction, instead of a linear or a non-linear inequality. So let's take a look. We have x over x plus 1 greater than 3x. So first of all, I would like to move all the terms to the left hand side. So on the right hand side, I only have a 0. So I subtract 3x on both sides. So I have the fraction minus 3x greater than 0. And then the next step is you have to get a common denominator. So common denominator, I would like to multiply the top and bottom of 3x by x plus 1. So x over x plus 1 and then minus. So this is a 3x, x plus 1, and then the denominator is x plus 1 greater than 0. And then you distribute the top. So this will be a minus 3x times x. So let's draw a line. Fraction bar. So we have x. I have a minus 3x times x. So that is a minus 3x squared. And then minus 3x times positive 1, we have a minus 3x. And then a common denominator, x plus 1 greater than 0. All right. So here you have to make a note. Do not multiply both sides by x plus 1 or you will lose a solution. Okay, so let's make a note right here. So do not multiply x plus 1 on both sides. Do you know why? So both sides. Because there is an x in here. So there is a variable and then here is a 0. When you multiply both sides by x plus 1, the x plus 1 is gone. So you lose an x plus 1. Then you are losing something in your answer. So don't do that. So in fact, I want you to clean up the numerator and then factor completely. So the numerator, you have x minus 3x. So therefore, you have a minus 2x. Then you have a minus 3x squared minus 2x divided by x plus 1 and then greater than 0. And then can you factor completely for me? So I will just factor our negative x, and then I have a 3x plus 2 divided by x plus 1. So check out the top and bottom. Make sure nothing else can be factored. So greater than 0. So factor completely. And then do you see that we have a fraction over here? Factor the top and bottom completely. And then after that, you have a fraction. So whenever we see a fraction, what do we have to think of? We have to think of that we cannot have a 0 in the denominator. So the next thing that you have to think of, so we are moving to the next stage. Just let me switch to a different color. So on the next stage, no 0 in the denominator. So that tells me x plus 1 cannot equal to 0. So therefore, x cannot be equal to negative 1. Because when we set up the interval, we have to mention this in our interval. X cannot be equal to negative 1. And then what else? And then the top here is what else we do. And then on the top, so let's switch to this. So on the top, you have to set that equals to 0. So negative x and then 3x plus 2 equals to 0. Do you know why? How do you get a 0? A numerator divided by denominator. Don't look at this problem. Just think about this in your mind. A numerator divided by a denominator equals to 0. So in order to equal to 0, the numerator must be equal to 0. So therefore, I set the numerator equals to 0. Okay, so this is negative x equals to 0, and then 3x plus 2 equals to 0. You have x equals to 0 and x equals to negative 2 over 3, right? So they make the fraction equal to 0. So they make the fraction equal to 0. All right, so they make the fraction equal to 0. And then the next step is we will have to draw our interval. So how many zeros do we have? So our zeros our zeros are. So we have x equals to 0, negative 2 over 3, and then also the x not equal to negative 1. X not equal to negative 1. I have to mention all three numbers on my number line. So let's go ahead and draw my number line. So I'm going to draw my number line right here. All right. So from which one is the smallest? We have negative 1, right? So we have x equals to negative 1. So x equals to negative 1. Just draw a negative 1. And then we have a negative 2/3. So we have a negative 2/3, which is approximately equals to negative 0.67, approximately negative 0.67, and then we have a 0. All right, so we have number line, we have three numbers, so one line, three cut, you divide the line into 4 pieces, right? And then each piece is called a test interval, right? So each piece is called a test interval. So we have test intervals. The first one is from negative infinity to negative 1, and then from negative 1 to negative 2/3, and then from negative 2/3 to 0, and then the last one is from 0 to positive infinity. So which interval is my solution set? We don't know yet. We have to test every single one of them. So that's why we have to pick a test value within each interval. So this one picks something easy. X equals to negative 2. That one is negative 0.67. I will pick a negative 0.8. This one I will just pick x equals to negative 0.1. So negative 0.1. And then the other one I will just pick x equals to 1. X equals to 1. All right. Okay. Let's do the plugin. So we have testing the sign of each factor. Each factor where? Right here. See this? How many factors do we have? We have a negative x, we have a 3x plus 2, and then we have a x plus 1. So we have to see the sign of negative x, and then also 3x plus 2 and x plus 1. So this will be a negative 2, negative 0.8, negative 0.1, negative 1. So this is definitely positive, 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 positive. All right, how about the next line? So 3 times x plus 2, 3 times negative 0.8 plus 2, 3 times negative 0.1 plus 2, 3 times 1 plus 2. I can see that this is definitely positive. And then negative 6 plus 2, negative. And then this 3 times negative 0.8, negative 2.4 plus 2, still negative. And then negative 0.3 plus 2, you have a positive. Almost done. And then the last one, you have negative 2 plus 1, negative 0.8 plus 1, negative 0.1 plus 1, and then 1 plus 1, definitely positive. This is definitely positive, but this is negative. All right, and then now we reach to our conclusion. So here is our conclusion. What is our factor form? Our factor form is right here. So this is our factor form. So let's bring that down. So we have negative x and then 3x plus 2 divided by x plus 1, right? X plus 1 greater than 0. So here is our conclusion. Okay, now let's do the multiply. So we have a negative x times that divided by that. So this is positive times negative, which is negative. Negative divided by negative, you have a positive. Positive times negative is negative. Negative divided by positive is negative. And then positive times positive divided by positive, definitely positive. And then the last one, negative. Oh, do you see that I make a mistake right there? I think most people caught me already. Negative 1, negative. So negative times positive is negative. Negative divided by positive is negative. Okay, so which one are we picking? Again, we have the fraction greater than 0. What kind of number is greater than 0? Positive or negative? The answer is positive. So we are picking this positive and then this positive. So here is my conclusion. I'm going to draw the number line one more time, and then I will bring the number down and then 0. So can x be equal to negative 1? No, no negative 1, right? And then I have a tutor, I have a 0. This, you want that, so you want everything in between them, and then you want x less than negative 1, and then there you go. Do we use any solid circle? The answer is no, we do not use any solid circle. Why? Because there is no equal. There is no equal. Okay, another what if? What if there is an equal? So if there is an equal, and then do you see that when x equals to 0 and negative tutor, we have a 0 on top. So if this is equal to, then we have solid circle and a solid circle, but this is still an open circle. Once again, when there is an equal, you have a solid circle and a solid circle, because when x equals to these two numbers, you have a 0 equals to 0. But when x equals to negative 1, the fraction is just undefined. So this is always an open circle, even though you put an equal right over there. All right, so let's draw our conclusion. So this will be negative infinity to negative 1, and then this is negative 2 over 3 to 0. So whenever you select a value that satisfies the inequality, the value must be within either this interval or that interval. So for the inequality, we have x less than negative 1, x between negative 2/3, and 0. And then there you go. That is the end of this problem. If you think this is helpful, this is something that you would like to see, stay tuned for more video. Give this video a thumbs up. And I will meet you all in the next lesson. Signing out.